Welcome to 3 Inquisitive Kids Unit 3, everybody. And today we will be looking at Chapter 3, Intro to Algebraic Expressions. Okay, so for the course outline today, we're going to be diving into Intro to Algebraic Expressions Part 1. And this will be a lot of building off from what we learned from the last lesson, variables. So our learning goals for today is 1. Understand the concept of algebraic expressions and being able to use algebraic expressions to express quantitative relationships in simple problems. And 2. In specific situations, you can find the value of an algebraic formula and explain its meaning. So let's start off with a quick little exercise of Intro to Algebraic Expressions. This summer, Rose set off from Shenzhen and traveled to Beijing with a tour group. Although she was fully prepared, she still encountered many math problems. Can you help her out? Tour 1. Preparation. The temperature in Shenzhen is X degrees Celsius. The temperature in Beijing is 4 degrees Celsius lower than that in Shenzhen. And the temperature in Beijing is blank Celsius. So we did some of these problems from the last lesson. And let's look at the problem. The temperature in Shenzhen is X degrees, and the temperature in Beijing is 4 degrees lower than that in Shenzhen. Lower, usually we think of minus or difference. So we would use the operation subtraction. And since the temperature of Shenzhen is X degrees, we can write it as X minus 4 Celsius. Tour 2. Set off. This distance from Shenzhen to Beijing is S kilometers, and the speed of the high-speed rail is 300 kilometers per hour. So it takes blank hours to reach Beijing. So let's review the problem. The distance from Shenzhen to Beijing is S kilometers, and the speed of the high-speed rail is 300 kilometers per hour. Well, if we have this much kilometers in all, in each hour, the high-speed rail can go 300 kilometers. Now, let's write an expression to express that. Over here, it could be expressed as 300 times h equals, by the way, h stands for hours, is equal to s kilometers. So if we want to figure out h, because that's the hours here, we could just divide a 300 on both sides. That would give us h equals s divided by 300. So here, the answer is s divided by 300 hours to reach Beijing. Tour 3. Buying tickets. We have A adult and B students. Tickets need to be paid blank dollars. It says that the ticket prices is $60 for every adult and $20 for every student. So what we need to figure out is the dollars that goes to the adults plus the dollars that goes to the students. So that would give us the total number of dollars that were spent. If we want to figure out the dollars that were spent on adults, that could be written as 60A plus the dollars of the students. So that's 20B. Because remember, there's $20 for every student. So that's 60A plus 20B dollars. Tour 4, visiting. The Hall of Supreme Harmony occupies a rectangular area, m meters long and n meters wide. How many square meters does the Hall of the Supreme Harmony cover? And the answer is blank square meters. Again, let's think of it. So it's a rectangular area. It's an area. And it's m meters long and n meters wide. So basically, it's asking for the area of this building. And we know that it's m meters long and n meters wide. To find the area, all we have to do is multiply the length and the width, so that's mn. Remember, we can omit the multiplication sign. So it's mn square meters. Tour 4, visiting. Tour 4, visiting. Continued. The exhibition hall of the Treasure Museum is a square with a meters on each side. How many square meters is the floor area? So please note that it's a square with a meters on each side. So that's basically a times a. But remember, if it is the same value multiplied again with itself, it's basically that value square. And that is the answer. A squared square meters. Tour 4, visiting. There is a gold-embedded pearl gem tower in the treasure hall. Outside the pearl gem tower is a rectangular glass cover. Its length, width, and height are 3 meters, p meters, and q meters. What is the volume of its glass cover? Now we have 3 variables, but don't worry and stay calm because this is nothing more than what we've encountered before. To find the volume of this glass cover, we need to multiply the length, width, and height, so the dimensions of the glass cover. And it's already given 3, p, and q. And since we multiply them all together, the multiplication sign can be omitted, and the answer is just 3pq. That's the answer. After that little warm-up, let's do some concept learning. Like x minus 4, s over 300, 60a plus 20b, mn, a squared, and 3pq. The expressions are all formed by connecting numbers and variables with operations called algebraic expressions. Operations may include addition, subtraction, multiplication, division, and exponents. Classic case analysis. Example 1. Which of the following algebraic formulas are considered algebraic formulas? Which ones are not? Pause the video and try to figure that out by yourself. So the first one is an algebraic formula because it is a variable and a number being connected by some sort of operation. Second one, it is not an algebraic formula because over here, as you can see, it isn't just connected by operation symbols, it was also connected by relation symbols, like with an equal sign. So this is not considered an algebraic formula because algebraic formulas cannot contain greater than, less than, equal sign, anything like that. 3 is an algebraic expression because algebraic expressions could even just be a single variable or number, and 0 is a single number, so that means it is also considered an algebraic formula. 4. Yes, it is because it is variables and numbers being connected together with operations. 5, no, it is not. Again, it is the same situation as the second one because there is a relation symbol. X plus y is greater than 1. That is not an algebraic formula because it shows some sort of relationship. 6. 1 divided by x, yes, that is definitely an algebraic expression because it is connected with the symbol division between a number and a variable. Notice, the algebraic formula does not contain operations that represent relations such as equal sign, greater than, less than, greater or equal to, less than or equal to, or unequal to. And 2, a single number or variable is also considered an algebraic expression. These are two very important notes when we're learning about the concept of algebraic expressions. So if you have a notebook or anything, please note that down because that is something, because notes is a really helpful way to memorize stuff. And when you're writing down knowledge that you're writing, it actually helps with you memorizing that fact. So take a moment to kind of jot this down, jot this information down. Okay, so let's move on to the real practices. Determine which of the following formulas are algebraic and which are not. Okay, this is not much different from what we encountered for the last problem. So the first one is correct because that is two variables being connected with an operation. The second one is also correct because it is two variables connected with division. The third one is not an algebraic expression because it has a equal sign. 4 is a single number, and that is also algebraic formulas. A is not equal to B, that shows relationships, so that is also not an algebraic expression. And that's also the same for number 6. It is x plus 2 is greater than 3, and that also in fact shows relationship. Example 2. Suppose number A is x and number B is y, and express the following in algebraic expressions. These are all statements that you need to write down and corresponding algebraic expression that is being described by these statements. So write those down on a sheet of paper and unpause the video to check your answers. The first one, it says the second power of the sum of A and B. That would be the sum of x plus y squared because you always have to see that what's talking about here is the sum of A and B. It's not just second power of A, it's the second power of the whole sum of A and B. 2. The sum of 2 times A and 1/3 of B. That is 2 times A and 1/3 of B. Remember, of usually means multiplication. So that's 2x plus 1/3 y because it's the sum. 3. The difference between A and B. Okay, I'm not sure why I wrote squared here, but the correct answer is x minus y for the third one. If you got that, you were correct. 4. The sum of the second power of A and B. Over here, the correct answer for 4 is x squared plus y because it's just the second power of A, of number A. B was not included in there. Example 3. The flow speed of a river is 2.5 kilometers per hour, and the speed of the ship is in still water is v kilometers per hour. The formula expresses the speed of the ship when it travels along against the current in the water. Over here, it actually means write a formula that expresses the speed of a ship when it travels against the current in the water. Pause the video and do that. So here's our analysis here. So when it's traveling down the water, the speed of the ship is equal to the speed of the ship in the water, in the still water, plus the speed of the current. But when it's traveling against the current, the speed of the ship is equal to the speed of the ship in the water minus the speed of in still water minus speed of the current. The solution would be 1. The speed of the boat traveling along the river is v plus 2.5 kilometers per hour. The speed of traveling upstream is v minus 2.5 kilometers per hour. One is going along the river and the other one is going against the river. And if you don't really get this, you may want to watch this again. You might want to do a little research of your own. You might want to relearn some stuff. Or you could be learning this right now, and then this is something that you are new to. Always remember to write that down in your notes. Pause the video and write down this right in your notes. Did you write it down? Great, because we're going to be doing some other these problems later on. Now let's take a look at the second problem. You need X dollars to buy one basketball, Y dollars to buy a volleyball, and Z dollars to buy a football. The formula represents the total amount of money needed to buy 3 basketballs, 5 volleyballs, and 2 footballs. So pause the video and write down a formula that you can use to express the amount of money that are going to be needed to buy 3 basketballs, 5 volleyballs, and 2 footballs. Well, let's think about it. The problem already told us that for every 1 basketball, there's going to be X dollars. And if we have 3 basketballs, that's going to cost us 3X dollars. Then we know that there are Y dollars to buy every 1 volleyball, and since there are 5 volleyballs, that's going to cost us 5Y dollars. And the same with the next one. We have 2 footballs, and each football costs us Z dollars, so that's 2Z dollars. And that is going to be our answer. 3X plus 5Y plus 2Z dollars. So here's a solution. Buy 3 basketballs, 5 volleyballs, and 2 footballs. And then the cost is going to be needed 3x plus 5y plus 2z dollars. Next, as shown in the picture below, unit of length in the picture, cm, centimeters. Use the formula to express the area of the triangular ruler. 4. The figure below on the right is the floor plan of a house. The net length in the figure, meters, which expresses the building area of this house. So the first problem I want you to pause for is figure out what is going to be the formula, use a formula to express the area of the triangular ruler. Now pause the video and do just that. All done? Okay, now let's see. We first calculate the area of this whole triangle here without looking at the area of the circle, and that's going to give us 1/2 AB. And then we're going to subtract the area of the circle. So that's going to be pi times r squared. So our formula is going to be 1/2 AB minus pi r squared. And remember, when we are asked to use a formula to express the area of something, you can go back to when you were just learning the formula of how to find the area. And then remember, you can always use variables to express the next. The figure below on the right is the floor plan of a house, which expresses the building area of this house. to use an algebraic formula to express the whole area of this house, just looking from the top. So really all we have to do here is figure out the area of each of these small portions of the house and then add them together, which would give us x squared plus 2x plus 18. It would actually be x squared plus 2x plus 12 plus 6. We can actually add this together, which gives us 18. So that's the simplified version. So here are some columnar key points. To grasp the key words, clarify their meanings and their relationships such as sum, difference, product, quotient, and big, small, more, less, double, minute, reciprocal, opposite, etc. You have to know the key words used in the scenarios if you want to figure out a formula to express that, because you got to know what operation to use or what relationships there are. So knowing all of these keywords is going to help you identify what operation to use and how to put it in there and what the relationships are. 2. Clarify the level of sentences and specify the order of operations. So if, say, there's a longer problem and then it went like, first there was this and then he did this, then they came over and did this, you got to have a clear kind of animation in your head of what's going on in that problem, what's the scenario, and what you need to figure out. And you have to clarify the level of the sentences, and you have to be able to identify the order of operation and the operations to use. 3. Keep in mind some concepts and formulas. One of the concepts could be like the commutative law of multiplication. You can know that AB is equal to BA. When in some problems, it's going to help you kind of say, well, if I know this, then I can do that. Or the other way around. It's going to help you relate to the problem. And another formula could be to find the area of a circle. That's going to be pi the radius squared. So those are the formulas, and you have to kind of get really, really quick with them. So later on in these hard, trickier problems, you quickly know and can identify which formulas were included and what formulas to use. Now let's do some practice. 1. A certain project is $4.8 per month, M. Use an algebraic formula to express the number of dollars in any month. 2. The radius and height of the bottom surface of a cylinder is r and h respectively. Use a formula to express the volume of the cylinder. 3. There are 2 cotton fields, one with m squared, with an average yield of A kilograms of cotton per hectare, the other with n hectares squared, with an average yield of B kilometers of cotton per hectare. Use an algebraic formula to express the cotton in the 2 cotton fields of the total output. Also remember here, this is A, that's a variable. And 4, dig out a small square iron piece from a large square iron piece. The side length of the large square is A millimeter, and the size length of the small square is B millimeters. So that's also another variable, A. Use a formula to express the area of the remaining part. Pause the video and do all of these problems by yourself, and then unpause to reveal the answers. Okay, so the first answer to the first problem, that's 4.8 M, because there is $4.8 per month, and there are M months, so that's 4.8 M. 2. The radius and height of the bottom surface of a cylinder is, well, the answer is pi times r squared times h, because figure out the base area of the cylinder and then we multiply the height. This is the base area, that's the height. 3. The answer is am plus bn kilograms because one has m hectares and a kilograms per hectare, so that's am, plus the other one has n hectares with an average of b kilograms of cotton per hectare, so that's am plus bn kilograms. 4. Take out a small square iron piece from a large square iron piece. The side length of the large square is a millimeters, so that's a millimeters. The side length of the small square is b millimeters. Use an algebraic formula to express the area of the remaining part. Well, over here you have to pay attention that each iron piece is a square. That means the four lengths are equal. So all we have to do is subtract the area of the smaller iron piece from the larger iron piece. So that would be a squared, that's the larger iron piece, minus b squared. That's also the answer. A squared minus b squared millimeters squared. Explain the actual meaning of algebraic expressions. Think about it. What could algebraic expression 10x plus 5y mean? If x is used to represent the price of a pencil and y is used to represent the price of a workbook, then 10x plus 5y can represent the total amount of money used in 10 pencils and 5 workbooks. Example 4. What could the following algebraic expression stand for? 1. 2a minus b, and 2. 2 times the difference of a and b. The first one could be a box of apples, a kilograms, and 2a minus b can represent the weight of the remaining apples after Aiden bought 2 boxes of apples and gave b kilograms to his friend. The second one could be Aiden does a math problem in each day on average. Brooklyn does b math problems a day on average. 2 times the difference of a and b can represent the number of math problems that Aiden does more than Brooklyn in 2 days. Practice in class. 1. Use formulas to express the following quantities. 5 boxes of apples weigh m kilograms, so each box weighs blank kilograms. 2. A number 5 less than 2 times a, this number is blank. 3. The total number of students in the school is x, of which girls account for 52% of the total. There are blank girls and blank boys. 4. There is a student in the class, and now distribute a batch of books to the whole class for reading. If there are 4 books for each person and 25 are missing, then there are blank books in total. Okay, so the answer to the first problem is m divided by 5 kilograms, because there is 5 boxes of apples and in total they weigh m kilograms. So if you want to find the weight of one box, you'll have to divide the number of boxes from the total weight. So that's m divided by 5. 2. A number less than 2 times a, then this number is 2a minus 5. Because you first have to multiply 2 and a, that's 2a, and then you have to have 5 less than it, so that's minus 5, 2a minus 5. 3. The total number of students in the school is x, of which girls account for 52% of the total. There are 0.48x girls and 0.52x boys. Okay, so don't get me wrong, this is actually supposed to be in different places. So there's supposed to be 0.52x girls and 0.48x boys, because it already told us that it's 52%, and we can write that as 52 over 100 times x, which is also the same as 0.52 times x, 0.52x. So there's 0.52x girls and 0.48x boys. Remember, x is the total number of students in the school. 4. There's 8 students in a class, and now distribute a batch of books to the whole class for reading. There are 4 books for each person, and 25 are missing. There are blank books in total. So there are going to be 4a minus 25 books in total, because there is 8 students in the class, and then each person has 4 books, so that's 4a, and then 25 books are missing, so that's minus 25. Also, what we were trained to do in these problems was that you had to be aware of keywords. For example, there's words like each box weighs, or a number less than 2 times a, or the total number of students in the school is x, of which girls account for 52 of the total. And then the last one has each person and 25 are missing. So these are all keywords that give you clues of what operation you could use in your formula. So as we get later on with these problems, you have to be really aware of all of these keywords. So yes, just be really aware of these keywords, because they could mean something. They could give you a clue to the answer. Tip: determine which of the following are not algebraic expressions. Pause the video and write an X to the ones that are not algebraic expressions, and write a check to the ones that are. And unpause the video after you're done. Okay, so the first one is correct. The second one is also correct. So figures 1, 2, 3, 5, and 10 are algebraic expressions, and 4, 6, 7, 8, and 9 are not algebraic expressions. So check your work and see if you were correct or not. And remember, if there are any signs that show relations like equal signs or greater than and less than, those are definitely not algebraic expressions. And one single variable or number is also considered an algebraic expression. 3. The ticket price of a certain park is $10 per piece for adults and $5 per piece for students. 1. A tour group has X adults and Y students. How much entrance fee should a tour group pay? 2. If the tour group has 37 adults and 15 students, how much entrance fees should they pay? How much should they spend on entrance fees? So pause the video and then see if you can solve these 2 small problems by yourself. And then after, you can unpause to check your work. Okay, so the first problem is 10x plus 5y. It already said that there's $10 per piece for adults, for one adult, and then there is x adults, so that's going to be 10x. And then we have to add the amount for the students, and there are y students, so that's $5y for the students, so that's 10x plus 5y. 2. Take x equals 37 and y equals 15. Substitute these values into the algebraic expression. Then you get 10x plus 5y, which is equal to 10 times 37 plus 5 times 15. And then remember your orders of operations. So you have to simplify that, and then you're going to get the answers 445. Therefore, they pay $445 for the entrance fee. 4. Modern nutritionists use body mass index to measure the degree of body weight, which is equal to the quotient of the body mass, kilograms, and body height, meters squared. For adults, the body mass index is 20 to 25, and the weight is moderate. Body mass is below 18 is underweight, and body mass index above 30 is overweight. Now, the problem is, suppose a person's weight, W kilograms, and height, H meters. So then you have to find his body mass index. Using the information given you in this problem, and you might have to highlight it, pause the video, and then help him find his body mass index. Okay, well, the problem already told us all the things that we need for the operations, really. It said that the body mass index is equal to quotient of body mass and body height squared. And this can give us the formula. The body mass is going to be, I'm just going to call that A. The answer is going to be equal to the quotient of the body mass and body height squared. So that's going to be the body mass, W, divided by, that's the quotient of the body height squared. The body height is h, so that's going to be h squared. You probably remember from our last lesson, it's not really standard to write it this way, so we can write it again in fraction form. W divided by h squared, still the same thing. So let's see if this was correct. It is. Solution, his body mass index is W divided by h squared. 2. Nick's height is 1.75 meters and his weight is 65 kilograms. Is his weight moderate? Again, all the information you need to solve this problem is already given in the scenario itself in the problem. So right now you may have to copy this question down, and then I can show you the original problem, and then you can solve the problem on your own. So here's the problem, and here's the scenario. Are you all done? Okay, so let's check if you were correct. So in the problem, it already talked about something being moderate. It said that for adults, the body mass index is 20 to 25, and that is going to be the moderate weight. So all we have to do is figure out if Nick's, after we calculate his body mass index, is it going to be moderate? So let's calculate that. Using what we already learned from the last problem, we know that it's going to be 65 divided by 1.75 squared. All you do is simplify this equation, and that would be close to 21. So all you have to do is substitute them into the algebraic expression, and then you can get the answer is probably around and close to 21. So basically, you're just gonna have to kind of get an answer that's close to 21. So which makes 21 moderate because it's between 20 and 25. That means his weight is moderate. class summary. This is going to be the very ending of our class, and I hope that you were able to understand the parts that were explained throughout this video. And remember, as always, if you didn't get anything, just go back and rewatch that part. If it was still unanswered, you can just reach out to us in the comments down below. So, we learned about algebraic expressions, and it splits into three centers. First, there's algebraic concept, and then there's list the algebraic formula according to the actual problem, and then explain the actual meaning of algebraic expressions. So, the algebraic concepts were algebraic writing requirements and discriminant algebra. And this is a whole map out of our lesson summary. Also, another good idea or tip to give you is you might want to always keep in hand in every of these lessons a small notebook to help you take notes and jot down the important parts of the lesson. Later on, if you're going to be doing any practice problems, you can't just cheat and come back and rewatch this video. And when you're practicing, you have to be able to rewrite the information down, the important ones. And that is actually going to help you learn it better. It's going to help you memorize it in your brain. So it's good to either listen to it and then after you can write that down. You can jot that down in your notebook. So that's a tip that I'm going to give you for these lessons. And then I hope that you're going to follow it or take notes in some other way. So here is what we learned. Our first skill was to understand the concept of algebraic expressions and being able to use algebraic expressions to express quantitative relationships and quantities. Second skill, in specific situations, you can find the value of an algebraic formula and explain its meaning. So I hope you learned something from this video, and it's just really nice to have all of you watching our videos that we're making. And keep being on the lookout for our next video that's going to come up because we're going to be starting to get into part 2 of algebraic expressions and their concepts. So please remember, start getting a notebook with you when you're at these lessons. And remember, if you want to learn more about us, always remember to go down in the description down below, read that, and then you can know exactly where to reach us. So please remember to subscribe, add a thumbs up, and we're going to see you next time. Stay inquisitive.